My fiance and I have a sweet corgi named Tubbs. Corgis are excellent dogs because they are loyal, smart, and cute. Also, I think everyone knows about their short little legs and adorable corgi butts and sploots. What some people might not know is that there are even Welsh legends about how corgis once served as noble steeds for fairies riding into battle. As if that wasn't enough, once you own a corgi, your family and friends will keep giving you corgi merch almost non-stop. Another often underlooked attribute of corgis is that they're basically the eevees of the dog world. For those who don't know, Eevee is a Pokemon that is capable of evolving into many different forms. Depending on what type of evolution stone is used, Eevee can become Flareon, Vaporeon, Jolteon, and I think you get the point. Corgis are kind of the same in the sense that whenever a corgi mates with a different dog, the puppies end up being an adorable short version of the original dog. For instance, here's a corgi German Shepherd mix, a corgi Pomeranian mix, a corgi Husky mix, and last but not least, a corgi Golden Retriever mix. Tubbs won't ever be able to evolve into these adorable mixed corgis, but I still kind of want to see what he'd look like if he was a Golden Retriever mix. One possibility is to just use Photoshop, but I kind of suck at it. Instead, I'll use AI to turn corgis into golden retrievers. As a little background about me, I'm a PhD student studying computer science. As a disclaimer, I do work under the umbrella of artificial intelligence, but I don't really research computer vision, which is really what this topic falls under. Before we get back to the project at hand, I think it's worth talking about what AI actually is. In terms of the general public, I would guess that most people's main point of reference for AI are in popular culture. HAL 9000 in 2001: A Space Odyssey, Skynet in Terminator, The Matrix in The Matrix, Sunny in iRobot, WALL-E in WALL-E, Scarlett Johansson, Samantha in Her, half the characters in Westworld, Mark Zuckerberg from Facebook, Gaia in Horizon Zero Dawn, the Geth in Mass Effect, and so on. Anyway, there's a ton of characterizations of AI, some of which are positive. Think of WALL-E, who works so hard to save the roly-poly humans. Or neutral, think of Samantha and Her, who just kind of leaves humanity behind. However, most of these characterizations of AI are negative, whereby they kind of just end up trying to destroy humans. Think Westworld, or kind of try to manage them in a dystopian way, like in The Matrix. But most of these examples of AI are what we call artificial general intelligence. The general and artificial general intelligence is in contrast to modern AI research and applications, which are pretty specific and sometimes referred to as narrow AI. In fact, because the problem of AI is so big, it's often broken apart into specific subproblems, including knowledge representation, which refers to how computers can represent concepts and relationships between those concepts, perception, which refers to how computers can see and understand our world, manipulation, which refers to how computers can interact with their environment, and the biggest one of all is learning, which refers to finding patterns in data or in human understanding. So AI is this big general concept that encompasses many smaller things. In terms of academic research, there's typically two main fields. One is robotics and the other is machine learning. Robotics often encompasses things like learning, perception, and manipulation, and it often ties these concepts together into a single entity. Maybe something like, a robot dog. In contrast, machine learning focuses on learning patterns, typically in terms of data that has already been perceived and processed into a format that machines can understand. When this data is language, we call it natural language processing. When it's images, we call it computer vision. In general, machine learning aims to either understand how different samples and data relate to each other, which we call unsupervised learning, or it aims to transform data into a prediction, which we call supervised learning. I'd say that this presentation of AI doesn't really look like the scary doomsday scenarios a lot of people are obsessed with, which kind of begs the question, why are people so obsessed with it? One reason is deep learning. Deep learning is a subcategory of machine learning that trains models called neural networks. Neural networks are a flexible type of model that are loosely inspired by human neurons. They look roughly like this, where we start with data, typically a vector of numbers, and want to predict an output, which is just another number. In a neural network, we use layers of neurons, where each neuron is a weighted combination of everything in the previous layer. Then, we train everything by optimizing a loss function, where we can continually gradually improving the weights. These types of optimization are generally how machines learn. This is also potentially where the fear of artificial general intelligence comes from. For instance, optimizing for human lives could result in a solution where humans are sequestered into a simulated reality, where all their needs are provided for and they are free to do literally whatever they want. Anyways, Going back to neural networks, it should be said that they have been around for many decades, but have only recently exploded in popularity due to the so-called deep learning revolution in 2012. They were shown to work super well for a variety of applications, including image and object recognition. Since then, deep learning has become integral to most sophisticated systems that work with text or image data. Think filters in Snapchat or TikTok, or text translation systems. But what caused the so-called deep learning revolution? I'm not sure if there's a definitive cause, but in my opinion, one of the biggest factors was hardware. Graphical processing units, GPUs for short, had been developed to render graphics for things like video games. In contrast, central processing units are really good at running operating systems and a lot of basic applications like web browsers. By the point of the deep learning revolution, GPUs had advanced to a point where they became super efficient for matrix multiplication and convolution, which is exactly what deep models need. At this point, we're ready to go back to the problem at hand. We want to convert corgi images into golden retriever images and vice versa. To do so, we can use deep learning, and specifically we can use CycleGANs. CycleGANs are a type of neural network. Typically, machine learning models like these use paired data, where we use an input to predict an associated output. In contrast, CycleGANs use unpaired data, where there isn't a direct mapping between inputs and outputs. This is exactly the setting we want, where we have unpaired corgi and golden retriever images. For CycleGANs, the GAN part stands for Generative Adversarial Networks, which were actually a big part of the deep learning revolution. The generative part means that the ultimate goal of GANs is to generate new content. The adversarial part means that GANs are actually two competing models, a generator and a discriminator. If we think about training a generator model to make really good content, it's actually pretty tough. Like each time the generator generates new images, we have to tell it whether or not the images are good. Oftentimes, this means telling if images are realistic. Although that's something that you or me could probably do, it would be super expensive to do it manually, so instead we automate the process with the discriminator model. Making this process work with neural networks was a huge innovation, and it revolutionized the field of machine learning. We can see how this technology truly benefits us as a society by giving us a shape-shifting Bill Hader impersonation, and it also lets us fill in anime sketches based on style images. For CycleGANs in particular, they use a very specific type of model, and a cycle consistency loss. I'll explain it in the context of corgis and goldens. CycleGANs have two generators and two discriminators. One generator is devoted to making new corgi images, and the other is devoted to generating new golden images. Likewise, one discriminator is devoted to telling whether an image is a fake corgi or a real one, and the second one discriminates real goldens. Then, we train the models using the adversarial loss we talked about, where the generators try to make realistic corgis and golden retrievers, and the discriminators try their best to give the generators a hard time. The final component unique to CycleGANs is the cycle consistency loss, where if we go from a corgi image to a golden and then back to a corgi, we should get the original corgi image, and vice versa for a golden retriever. This tries to make sure that the original corgi resembles the generated golden, maybe by maintaining their pose, background, and other features. As with literally every machine learning project, the first step is data munging. To do so, I followed this project I found on the machine learning subreddit that generates a latent corgi space. All the corgis you see right now are generated and don't actually exist in real life. They scraped a huge amount of images from Instagram using hashtags to find corgis. In addition to their images, I scraped images myself with the hashtag golden retriever. One difficulty here is that Instagram doesn't really like it when people do this, so they set what are called rate limits, so you can only download so many images every hour. One solution is to just use proxy servers so they don't block your IP, but I ended up just writing a script to scrape around 200 images an hour, and after a week I had a dataset of 30,000 golden retriever images. The next steps include making sure images actually had golden retrievers in them, and that there was only one per image. This helps to set the deep learning model up for success by getting rid of really weird images. In order to do this, I used a pre-trained model that finds and classifies objects and images from image AI. After this, we use the bounding boxes to crop dog images to a standard square size and save all of those images. The first part was a bit annoying because there were many non-golden retrievers with the hashtag golden retriever. Sometimes it was mild like black labs, but sometimes people straight up hashtag golden retriever on dogs like these. I ended up manually removing a lot of them, but would probably try to do this in an automated way in the future. Maybe with an unsupervised clustering method. Now we can train our CycleGAN. Training happens iteratively, so we can see how the model gets better or worse over time. In order to take a look at the progress of the model, we can look at how the generated images look over the course of training. To make this a bit easier, I made a site to visualize the images, which I'll link to in the video description, and you can check it out for yourself. Alright, so here we have the visualization site. First, this is the one for generating golden retrievers from corgis, so these are all going to be corgi images. And at the top you can select different corgi images by clicking on them. On the bottom we see how the corgi gets transformed as the model gets more and more training. So this is very little training, and as we scroll to the right there's more and more training. Ideally the more training the better the transformations, but as we can see this is not always the case, where there's kind of these weird artifacts sometimes. So in this first image we can see that the coat changes very early on, and the original white fur turns golden pretty quickly. Additionally, their sable fur kind of gets saturated and turns more of this golden color, which looks pretty nice. In addition, the transformation actually somewhat gets rid of the corgi's ears, which is pretty remarkable because the model has to guess at what's actually behind the ears, which is actually hard for even humans to do. Other than that, we can see this transformation is pretty dang good and ends up looking like a cute little short golden retriever. Unfortunately for this image, as we train more and more, we end up finding an adversarial example, which basically means the generator found a way to deceive the discriminator that tries to tell if a golden retriever is real or not. By adding these weird pixels here, which we call artifacts, the generator is able to make kind of a fake golden retriever without really doing all the work. So it stops getting rid of the ears, and it kind of stops changing the coat because it found that these weird pixels is enough to deceive the discriminator that it wants to trick. But that's okay, it still did a pretty good job early on, and so we can kind of use these as the images that our model generates. We can also see a few other cute transformations, like this one, where the corgi gets transformed into an adorable little golden retriever. There's also this one where I think another interesting fact is that the model starts to shrink the corgi's eyes because golden retriever eyes are actually relatively small compared to corgi eyes for the size of their heads. So it actually makes the eyes smaller, which is pretty cool. Some of these transformations don't really work at all, which we can see with some of these. Specifically for corgis that are not that sable Pembroke Welsh corgi. These ones are kind of not as common in the data set, and so they probably just don't get enough samples for the model to do a good job of transforming them. For this one, it also doesn't really work because the corgi is in kind of an unexpected pose that isn't very common in the data set. A few others make some terrifying transformations, like this weird Joker corgi, whose smile gets stretched upwards. So it starts off kind of normal and continually gets stretched upwards into this horrifying Joker-ish smile. Finally, these are of our corgi tubs, where you can see that for some of these where the lighting conditions aren't really great, it matters actually a lot and ends up generating pretty horrifying pictures of tubs. It actually does a slightly better job for this brighter picture of him, where his face is more illuminated. It's still not great, and I think part of it is because he has this kind of black fur on his muzzle, which is not super common to Pembroke Welsh corgis, who typically just have the all white muzzles, like you can see here. Alright, so this is the analogous website for the golden retrievers, where we can see them being converted into corgis. So for this first golden retriever, we can see slowly over time, the coat definitely starts to change very quickly, especially on the face, and there's some lightning on the body as well. But most remarkably, you can see that it starts to hallucinate these corgi ears, which is pretty cool, because by the end of it, this golden retriever doesn't really have golden retriever ears, but has corgi ears, which point upwards. You can see some of the puppies, where the face starts to change as well. For this one, it kind of squishes the top of the head, and starts to try to hallucinate ears, but doesn't quite get there by the end of the training. For this one, it's kind of funny because initially it starts to transform the golden retriever, but eventually it confuses its tail for a corgi ear and basically turns its tail into an ear. For this one, it's kind of cute as well because it starts off with just kind of changing the face, but slowly makes these tiny little corgi ears at the top of his head. So he has tiny little corgi ears. But not all of these are successful. A few of them have kind of these horrifying, weird corgi ears just popping up in random places on the golden retriever. And this one, actually, they get rid of the body and turns the body into ears. And in a few of these, there's another fake ear. And for this one, it just totally didn't work and created this kind of demon golden retriever with these red eyes, probably because the lighting conditions are not so great. And finally, in this one, it just kind of hallucinates this weird spot on this dog's head, maybe because there's kind of a weird miscolored patch there. And it just gets exacerbated. Alright, while I'm wrapping up, I'll just show some more of my favorite transformations. All in all, this project was quite fun, but I definitely didn't do a perfect job. There's a few things that I would change if I did it again. One of the first things is that I use Google Colab, which gives you access to GPUs for free. The issue is that these GPUs are unreliable and they can disconnect whenever they want. So I ended up springing for the $50 subscription for 1 month, and it wasn't really that worth it either, because it still kind of disconnects randomly, so I had to periodically restart the model's training, sometimes multiple times a day. If I did it again, I would probably look into the GPU cloud services Google and Amazon provide instead. The other thing I would probably try to change is that I would have a more pure corgi dataset, where it was either all Sable Pembroke Welsh corgis, or maybe even for the Golden Retriever dataset, I try to make that more similar as well. One way to do this would be to use unsupervised learning methods that would basically group similar images, and then I can go in and exclude groups of differently colored corgis, or other images that might potentially be weird. Using all the lessons I learned, I'll probably do a version 2 sometime, maybe with corgis and huskies instead, because that might be easier. And maybe at some point I'll try a more sophisticated model than CycleGANs. If you want to see that, feel free to subscribe, and if you enjoyed this video, feel free to like it.